All right. So yesterday you guys took formative. I handed those back today, and so then those can be corrected sometime soon. Just remember that looking ahead. So we've got we're going to start section 4.2 today. It means nothing new because you guys don't have textbooks, but that's what we call it, section 4.2, because it comes out of section 4.2 in the old textbook. So we'll do that today. We'll do that tomorrow. And then we'll jump back into section 4.3, which is what we were in up to this point in time. We'll jump back into that next week. And then right now we are looking at on the 13th. So welcome to December, by the way. So on the 13th of December, we're going to take a test on sections 4.2 and 4.3. I also remind you that your unit circle extra credit projects are due 2 weeks from today. If you are doing a food-based product, I ask that you bring it to class so that then the class can share in your food-based product. If you are not doing a food-based product, you can bring it in at any point in time. They're due by 3 o'clock. Today you'll need your identities page, which is the pink cardstock page that you picked up on Tuesday. So you'll need that out. You should have that handy at all times for you going forward now here in class. Okay? So again, I don't want you to be working on formatives right now. I don't want to see them. Clear them off. Let's focus in on the task at hand. And the task at hand now is the notes, and it's a new topic today, so we need to definitely do that. So we need our identity sheet. Make sure that you're done with the trig values 1, trig values 2, and trig values 3 worksheets. So those will also be due on the 13th, along with a couple others. Okay? So here is a good warm-up problem for you. So given the fact that the sine of t is equal to negative 12/13. Okay? So the sine of t is equal to negative 12/13. I want you to answer me those 6 questions. Okay? Go for it. So we'll start with the first one. Knowing the fact that the sine is negative, what quadrants can theta be in? Can t be? This is from your obviosity. 3 and 4. Bottom half of the unit circle, right? Got to be below the x-axis because that's where sine is negative. So this would be quadrant 3 or quadrant 4. Okay. Sine is negative, lower half. Okay. Based off of our obviosities or off of your trig identities sheet, if the sine of, or what is the sine of negative t equal to? I want to say it's number 2. Negative sine of t. So that would be negative of negative 12/13 because negative 12/13 is equal to sine of t. So that means that sine of negative t would be equal to positive 12/13. Yes? Okay. C, sine of t plus pi. This one would be number 9. What would that one be equal to? The identity says it's equal to number 9. Number 9. Negative sine of t again. We just figured out what negative sine of t is. So this one would be equal to positive 12 13ths. D. Because it doesn't matter, because that's a full lap. We just went a lap clockwise instead of going a lap counterclockwise. Yep. So that's going to be equal to the sine of t. So that one would be equal to negative 12 13ths. Okay? I like it. Ooh, now, cosine of t. Do I have an identity that somehow links sine and cosine? What? The hammer. I got the hammer. So the hammer says that the cosine squared of t is plus sine squared of t is equal to 1. So I don't know what cosine squared is. I know that sine squared would be negative 12 13ths squared, and that's got to be equal to 1. Extend that page down here so we can do some more fun maths. Cosine squared of t plus, well, negative 12 13ths squared is 144 over 169. And instead of writing 1 as 1, I'm going to write it as 169 over 169. Subtracting 144 over 169 would give me cosine squared of t equals 25 over 169. Then I would take the square root, and I would get the cosine of t, which is what I'm looking for, is plus or minus, oops, I almost put 25 there, plus or minus 5 13ths. Cotangent is cosine over sine. So that would be plus or minus 5 13ths over negative 12 13ths. Keep change flip tells me 5 13ths times 13 over negative 12. This was plus or minus. So that gives me the cotangent of t is plus or minus 5 plus. The plus or minus takes over in place of the negative. Because if it's positive, then it's still negative. If it's negative, then it's positive. It's still plus or minus. Depends on which one. Questions on any of those 6? Fantastic. Yep. So now we're going to utilize our unit circle. Okay? But we're going to look, instead of asking for a specific value, like the sine of 11 pi over 6 is 3 pi over 2, I'm going to ask you for the sine of theta is 3 pi over 2. And you're going to have to give me the angle. Angle finding, theta finding, whichever one you prefer. Okay? So here on this first one, okay, now we gave you this other little tidbit here, that theta is an acute angle. So what's the only quadrant that you should be looking in? Yeah? Quadrant 1. We're only looking in quadrant 1 because theta is an acute angle. Acute angle is between 0 and 90. That's quadrant 1. Now, if we didn't say that, we would have multiple answers for all of these questions. Because, yes, cosine of theta is 3 pi over 2, so I'm looking for where the x is 3 pi over 2 in quadrant 1, which would be pi over 6. Okay? But also down here, at 11 pi over 6, the cosine is also 3 pi over, or square root of 3 over 2. Okay? So both of those would work, but because we restricted it to an acute angle, we're just going to say here pi over 6. Okay. Where in quadrant number 1 is tangent equal to 1? Where in quadrant 1 is tangent equal to 1? Pi over 4. Because x and y have to be the same, and that happens at pi over 4. Sine in quadrant 1 is 1/2. Where would that happen? Pi over 6? Because we're only looking for quadrant 1 angles. All right? Now, kick it up a notch. We've got plenty of unit circles around the room that you can look and see at, or what you ever want. Or if you've got your own, you can definitely look at your own too. Okay. So now, without using a calculator, I want to know where the tangent of theta is equal to the square root of 3 over, or just the square root of 3. Excuse me. Okay. So first off, theta is an acute angle, so again, I'm looking in quadrant. Do I need to look at pi over 4? Why not? Well, so we know that, but what also look at x and y at pi over 4? Do you see a square root of 3? No, so it's not just going to magically appear. So that one can be eliminated. Can I eliminate pi over 2? Yeah, no square root of 3 in that one. Can I eliminate 0? Yeah, no square root of 3 in that one. So I only got to look at pi over 3 or pi over 6. And it's going to be one or the other one. Okay? Okay? So if I'm looking here at pi over 6, because it comes first. So if I'm looking at pi over 6, tangent is y over x. So that would be 1/2 over the square root of 3 over 2. Keep, change, flip tells me that's 1/2 times 2 over the square root of 3, which becomes 1 over the square root of 3. Is that equal to the square root of 3? No. Okay. So then it's probably more than likely got to be, if it's possible, pi over 3. Let's check that one. Y value at pi over 3 is the square root of 3 over 2. X value is 1/2. Keep, change, flip. There it is. So this is pi over 3. You now, you find me where in quadrant 1, the cosecant of theta is the square root of 2. Cosecant is 1 over sine, which is 1 over y. In quadrant number 1, the only one that have the square root of 2 is pi over 4. So let's try pi over 4. over square root of 2 over 2. That, rationalize the denominator. On top, I've got 2 square roots of 2. On the bottom, I've got 2. Which that then just becomes square root of 2. So this would be pi over 4. Questions on that? So now, let's branch out outside of quadrant number 1. Okay? So in order to be specific in terms of the angle that we're looking for, we are going to give you not only what the trig value is, but we're going to give you some other condition, because we have to narrow it down into one specific quadrant. Okay? And so what we can do for that is we can, like in these two, we're going to limit where theta it can be located. That's one way of doing it. Another way of doing it is saying something like the sign is negative, or the sign is less than 0. Okay? Or cotangent is greater than 0. And we could give you some other condition that goes along with it. Okay? So the first thing that I look at is I look at here. Okay? Because I got to figure out where my angle is. Okay? So where on the unit circle, in terms of quadrants, now I'm talking, not in terms of actual angles. In terms of quadrants, where is cosine negative? In quadrants 2 and 3, right? Left half of the circle. Okay. In terms of my second condition, where is, on the unit circle, or what quadrant, I should say, what quadrant has theta between pi over 2 and pi? Quadrant 2. Okay? So where is this angle located? It's going to be in quadrant 2. Okay? So now I can go back to this purpley one, and I can say, where in quadrant 2 is the cosine negative root 3 over 2? Pi over 6. Yep. So theta here is 5 pi over 6. Questions, comments, concerns? You do those two. Again. All right. Where is tangent positive? Two quadrants. 1 and 3, yep. Which quadrant is represented here? That's 3, right? So I'm in quadrant number 3. Okay? I want my tangent to be the square root of 3 over 3. So my choices are either 7 pi over 6 or 4 pi over 3. Let's try 7 pi over 6 first. That's going to be the sign at 7 pi over 6 is negative 1/2. The cosine is negative root 3 over 2. Keep change flip says negative 1/2. times negative 2 over the square root of 3 gets me positive 1 over the square root of 3, which if I rationalize, I got the square root of 3 over the square root of 3, I get the square root of 3 over 3. Positive, that's what I wanted. 7 pi over 6 is. Side note, if you haven't written down somewhere that the over 6 is, the tangent is the square root of 3 over 3, and the over 3's, the tangent is the square root of 3, you should probably write that down. Okay? That'll save you some time. Okay? Number 3, cosecant. Cosecant is tied with what? Sine or cosine? Sine, okay? So where is sine negative? Because wherever sine is negative, that's where cosecant is negative. Sine is negative where? 3 and 4? Where is cosine positive? And 1. So where is my angle going to be? What quadrant? Quadrant 4, okay? Because it shows up in both conditions. So I'm looking in quadrant 4. Cosecant, we said again, was 1 over the sine of theta. So I need to know where sine of theta is 1/2, which happens to be at 11 pi over 6. 1 over negative 1/2 is going to be, oops, I should use equal signs because 11 pi over 6 is equal to that. But my thought process is this, 1 times 1 is negative 2, so that is theta here. Good times. Okay? So now what we want to do is we want to get into a little SOHCAHTOA. Okay? Get into a little right triangle trig. Just to refresh your memory from when last you were a tree in geometry. Okay? So in terms of a right triangle, and this only works for a right triangle. Okay? Wherever your angle is, so first off, the hypotenuse is always the longest side in a right triangle. It's across from the right angle. Okay? Biggest angle, biggest side. Smallest angle, smallest side. Okay? So adjacent would be the side that is touching the angle. So in this particular case, since theta is in the upper left portion of the triangle, the adjacent side is the vertical one. The opposite side would be across the triangle. That would be this one. If I switch and put I'll go beta instead of theta. If I go to beta now this becomes the opposite side. And this becomes the adjacent side. Okay? If I switch my angle, my opposite and my adjacent sides also switch. Okay? So SOHCAHTOA once again says that the sine of an angle in a right triangle is equal to the opposite side divided by the hypotenuse. So, SOH. Ka says the cosine is equal to the adjacent side divided by the hypotenuse. And TOA says that the tangent is the opposite divided by the adjacent. Okay? SOHCAHTOA. Much easier than some old horse caught another horse taking oats away. Late 80s. Marky Mark and the Funky Bunch, today's homeroom song.
Yeah, we jam to it always, us old folks.
Mm-hmm. Okay. So, if we are going to be solving for a particular variable, we first have to take a moment and we have to decide what is what. What do I have? What am I given? What do I need to find? Okay. So first off, do we have a right triangle? Yeah, because if we don't, we can't do any of this. Okay. So that should be your first, yep, I got a right triangle. I either see the mark or in the direction that says this triangle is a right triangle or something along those lines. Okay? So we have that. We have an angle. That angle is right here. What do I have in terms of the sides then? We have the adjacent, and we're looking for the hypotenuse, right? So which one deals with adjacent and hypotenuse? Cosine, ha. Okay? So the cosine of my angle is going to be the adjacent side divided by the hypotenuse. So we got that. Which gives us, make sure your calculator is in degrees, because that's what we're dealing with. You should see a D or a DEG somewhere on there. Cosine of 39. I get X is 29.59547,002. Okay. Typically, we'll have this in directions, but typically with sides, we round to 2 decimal points. Angles, we round to 1 decimal. So I would say here that X is 29.6. Find the X. It's right there. Let's see if there's some down here. Nope, no more down there. Good. So find the X. Sine deals with opposite and hypotenuse, so the sine of 66 degrees is x over 50. So x here would equal 50 times the sine of 66 degrees, which I get is 45.677272888. So I would say here that x is equal to 45.6. Good. classic problem that we would have in this right triangle trig type stuff would be to say, okay, here is your right triangle. You find me the 6 trig values that go along with it. Okay? So, one of the things that we also have in our toolbox, one of those old rusty tools buried in the back, is what for a right triangle? We have Pythagorean theorem. A squared plus b squared equals c squared. Sum of the squares of the legs is equal to the square of the hypotenuse. So first off, we can solve for h by saying, we could say 5 squared plus 12 squared equals h squared. 25, 144. That gets me 169. So that gets me 13. Okay? Or if you remember your Pythagorean triples, 3, 4, 5 is the most common one. Okay? Or 6, 8, 10. Or 9, 12, 15. Multiples of 3, 4, 5. Okay? 5, 12, 13 is the next one. And is it 7, 15, and 17? 17 squared minus, no, 8. 8, 15, and 17 is the next one. Okay? So knowing that my height here, or my hypotenuse is 13, now I can come up with the 6 trig values. So let's start with the cosine of theta. Cosine of theta would be 12 over 13, right? Adjacent over hypotenuse, which means the secant of theta would be 13 over 12, just its reciprocal. The sine of theta would be 5 over 13, which means the cosecant of theta, the tangent of theta, (5 over 12), opposite over adjacent, the cotangent of theta, 12 over 5. And there you found all 6 trig values of theta. You find me those. We get 2 square roots of 22 for the missing side. Yes? Square root of 88 is the square root of 4 times the square root of 22. 2 square roots of 22. Okay? So cosine of theta then is going to be 2 square roots of 22 over 13. Secant of theta is going to be 13 over 2 square roots of 22. Or you could go here 13 square roots of 22 all over 44. Sine of theta is going to be 9/13, which means the cosecant of theta is going to be tangent of theta is going to be 9 over 2 square root of 22, or 9 square root of 22 over 44. And the cotangent, not the cost, cotangent of theta is going to be 2 square root of 22. Yes? Good times. Good times. Questions, comments, concerns on anything we talked about today? Awesome. Thanks for playing along.